Welcome to GTech Techno Solutions Private Limited. In this unit, we will be studying about the general methods of preparation for ketones, that is mainly acetone. Primary alcohols give aldehydes, whereas secondary alcohols give ketones. That is because of the number of acidic hydrogens or the alpha hydrogens present in the compound. If we see here, we have a primary alcohol, namely ethyl alcohol or ethanol, which is made to react in the presence of potassium dichromate and H+ ion. We obtain acetaldehyde. That is because this hydrogen shifts here and takes this OH group away, making a double bond between the oxygen and the carbon atom. Whereas if in a secondary alcohol, this hydrogen atom attacks with this, and therefore there is no presence of hydrogen here. Therefore it forms a ketone. It can also be prepared by passing a mixture of alcohol vapors and air over silver catalyst at 520 Kelvin. Aldehyde or ketones are formed. If ethanol is taken in the presence of oxygen and silver catalyst at 520 Kelvin, we obtain acetaldehyde, whose general formula is CH3CHO. Similarly, when propanol is taken in the presence of oxygen and silver catalyst at the same temperature, we obtain acetone. It can also be prepared by the catalytic dehydrogenation of alcohols. The vapors of alcohol are passed over heater copper at 573 Kelvin, which obtained gives aldehyde or ketone. Similarly, take a primary alcohol at 573 Kelvin in the presence of copper powder, we obtain aldehyde, because one hydrogen group and one oxygen gets removed. Similarly, in a secondary alcohol, this hydrogen and this hydrogen breaks bonds, therefore producing a double bond between the carbon and oxygen, producing a ketone for a secondary alcohol. These are the practical examples of a primary alcohol and a secondary alcohol. For a primary alcohol, if we take ethyl alcohol, we obtain acetaldehyde. Similarly, if we take isopropyl alcohol, we obtain acetone. Let us now discuss about the dry distillation methods of the preparation of aldehydes and ketones. They can also be prepared by distillation of calcium salts, as we see here, or fatty acids with calcium formate. Aldehydes are formed. For ketones to be formed, we use the distillation of calcium salts of some fatty acids. For example, if we take 2 moles of calcium acetate and heat them, we obtain acetaldehyde along with calcium carbonate. Whereas if we heat only calcium acetate in high temperatures, we obtain acetone and calcium carbonate again. Next is an important reaction, Rosenman reduction. Acid chlorides are reduced to aldehydes by hydrogen in the presence of palladium suspended in barium sulfate as catalyst. As formal chloride is unstable at room temperatures, formaldehydes cannot be prepared by this method. This is called Rosenman reduction. If we take an acid chloride, as we can see here, and add hydrogen in the presence of palladium and barium sulfate, we obtain, this is what is an aldehyde, and hydrochloric acid as a byproduct. Next, if we take acetyl chloride in the presence of palladium catalyst and barium sulfate, we obtain acetaldehyde and hydrochloric acid. Barium sulfate is used as a catalytic poison to stop the reduction at the stage of aldehyde. Otherwise, the aldehyde formed will be further reduced to the primary alcohol. If we take an acetyl chloride here, as we can see here, and hydrogenate it, In the presence of palladium and barium sulfate, we obtain an aldehyde and hydrochloric acid as the byproduct. Similarly, acetyl chloride, at the same conditions, we obtain acetaldehyde and hydrochloric acid. Ketones can be prepared by the action of organometallic reagents on acid chloride. For example, if you see here, this dialkyl cadmium is a reagent of choice. We obtain dialkyl cadmium and cadmium chloride. The compound formed here is of the boat structure. It can also be prepared by the hydrolysis of gem dihalides. A gem dihalide is a compound in which two halogen atoms are attached to the same carbon. For example, if you see here ethyldiene and chloride, when reacting with sodium hydroxide, we obtain this compound. On hydrolysis, we obtain acetaldehyde. Aldehydes can also be prepared by hydrolysis of dihalides when two halogen atoms are attached to the same terminal carbon when an alkali like NaOH or KOH is used. Hydrolysis of gem dihalides in which two halogens are attached to the non-terminal carbon can also result in the formation of ketones. Example of halogens attached to a non-terminal carbon atom are 2,2 dichloropropane. When it is added to sodium hydroxide in the presence of water, we obtain this compound. This is because the two OH groups present here replaces chlorine, that is, substitution reaction takes place and the hydrogen is completely removed. So one molecule of OH and a hydrogen gets removed. So this oxygen forms a double bond with this carbon to form acetone. It can also be prepared by ozonolysis. Ozone forms addition product with olefin called ozonide, which on reductive cleavage gives aldehydes or ketones. Thus, if formaldehyde is obtained, that indicates the presence of a double bond at the terminal carbon. Hence, to locate the position of double bond, ozonolysis is helpful. It can also be prepared by the oxidative cleavage of 1,2 diols using periodic acids. C single bond C bond in 1,2 diols, as we can see here, is cleaved by periodic acid. Periodic acid is nothing but HiO4. When this is used, this bond here between the carbon and carbon is cleaved to form two types of aldehydes. Taking a practical example like butane 2,3 diol and using an periodic acid, the bond between the carbon and carbon is broken to form 2 moles of acetaldehyde. The same results for butane 2,3 dimethyl 2,3 diols. This also results in the formation of ketones and acetones respectively. Let us now discuss about the hydration of alkynes. By the hydration of alkynes in 42% sulphuric acid containing HgSO4 as a catalyst, acetaldehyde is obtained when acetylene is used. Using propane can also result in the formation of acetone. When acetylene is taken, this triple bond here is cleaved in the presence of H+ and Hg2+, that is mercury catalyst. Acetaldehyde is formed. If propyne is taken, the same thing occurs and the formation of acetone takes place. Stephenson's reaction. Stephenson's reaction is used in the preparation of aldehydes. By reducing the alkyl cyanide, which is dissolved in ether with Stannous chloride and HCl. For example, let us take an methyl cyanide as an example. In the presence of Stannous chloride and hydrochloric acid, we obtain iminium hydrochloride. This triple bond is cleaved to form a double bond between the carbon and nitrogen. Similarly, when this type of compound is taken and used for hydrolysis, we obtain acetaldehyde along with ammonium chloride. Thank you for watching a product from G Tech.